Thanks, Daniel. Hi, so I'm Jim, and I'm going to talk to you about Hopsworks, which is a new front end to a Hadoop distribution developed at SICS and KTH, so developed here in Sweden. We've been working on the platform for like 4 years, but the front end is, I guess, the last year of work. So this is more data engineering talk rather than data science. We've had a lot of data science today. And I guess part of the goal of Hopsworks is to get data engineering out of the way, because setting up platforms, getting them working is quite a time-consuming task. So the other thing that's happening that was mentioned earlier is that SICS are going to build a new data center. So this platform will be a service provided on the data center. So we're going to provide Hadoop as a service, and it will be different to Amazon. So you will get large amounts of storage, and you can run your CPU hours, and it should be easy to use, and you'll have large amounts of storage space. So it will have data locality as opposed to Amazon, where you're copying your data over S3. Okay, so I can tell you it's cool, but you mightn't believe me because you go, who's this dude? So here we have Leslie Lamport, Turing Award winner last year, and he's one of our supporters. So if he thinks it's cool, that's good enough for me. Okay, so what am I going to talk about? I'm actually going to talk a bit about multi-tenancy in Hadoop. So how do the existing distributions, Cloudera, Hortonworks, do multi-tenancy? How do we do multi-tenancy in Hopsworks? Some of the features that we have in Hopsworks, like free text search of the file system and extensible metadata. And then how do we do in analytics in Hopsworks? So we have Zeppelin, I'll mention briefly. So here's the starting point. So imagine you're building a data center up in Luleå and you want people to be able to create projects. But what you would not like to happen is that people who are maybe in this project X down here giving access to their data to this project NSA up at the top. So what we'd like to have is these projects isolated from one another. And that's what we call multi-tenancy. And that's quite, you can do that. It's not too hard a problem to solve. The problem you have then is if you have data that needs to be used in both projects, what do you do? So in the Hadoop world, accessing data across projects doesn't mean just copying data from one project to another. You can also write programs that take data from one source, another source, and cross-link it. But this is, in general, for many sensitive data sets, this is problematic, and particularly for companies. So I mentioned already, we also want to share data sets. So if we have a project that owns a data set, well, how do we share the data set? We don't want to copy the data, because that's going to be a waste of resources. So we'd like to enable people to authorize access to data sets. Now, those of you who know security will know this is kind of a well-known problem. I have a role maybe in this project and another role in this project, and we can swap our roles. So we make our roles dynamic, and then we get a solution. That's kind of what I'm going to talk about here. So just to make it a bit more concrete, imagine you have a database, and we want to do the same. We want to do the same problem, multi-tenancy. I have two databases, database 1 and database 2. I have two users, Alison and Bob. How do I ensure multi-tenancy here? Well, you can use statements like grant all privileges on a particular database, database 1 to Alice, and we give all the privileges on database 2 to Bob. And now they're isolated from one another. And you can go even lower down in the database. You can say, okay, I want more fine-grained privileges, such as read access on this sensitive table to Alice, so long as she's logging in from this particular IP address. And this is all fine and well. And what's really nice with databases is that these privileges can be linked to the actual data sources. So if you're using Oracle, for example, and you drop the table, the privileges will go away. If you're in MySQL, well, they kind of hang around. But that's an implementation detail. The point here is that privileges and the data sources can be linked together with foreign keys, and then you can keep them consistent. So having consistent policies for accessing your data with your actual data source is a good thing. Now, Hadoop doesn't do that at the moment, right? So at the moment, we have a couple of systems. One is called Apache Sentry, promoted by Cloudera. You also have Apache Ranger, promoted by Hortonworks. They always seem to have their own projects, these companies, Apache projects. But what they're doing here is you can see a big star here. So we have lots of different services, everything from Hive to Impala to HDFS to Hue. And they're all centralizing on this service called Sentry, which is backed by a database. And in this database, you write some policies. And the idea is that when you do anything in any of these services, you first check with your centralized policy enforcement engine, can I do it? The challenge with this is that, well, how can we maintain the consistency of the policies and the data? So if I create a table up here or drop a table up here in Impala, how do we make sure that any privileges associated with that also are consistent? So if the table doesn't exist but the privileges exist, is that okay? The other problem you have here is that really this is going to be a bottleneck, yeah? So what they're trying to do is introduce caching of policies at some of the higher performance services. But really, the other main issue is that how do we update our rules? So if I want to allow people to access my project, I say, well, I'd like to add this user to my project. Well, in the current Hadoop world, you go to your sysadmin, send them an email, and they'll go into a tool like this called Hue, and they'll enter a new, maybe a new user and map it to a group and map that group to a role. And it's quite complicated, okay? Then we have this problem of performance. So if my policy enforcement engine is going to have dynamic roles or something like that, you're not really going to get more than a couple of thousand ops per second out of it. That's with caching. And that's a problem, right? Because Hadoop is fast. Hadoop can, our file system can handle 100,000 ops per second, but if our policy enforcement engine can only handle 2,000 ops per second, you can't hook one up to the other. They just don't work together. It's like, drawing a sports car, pulling it with some horses that can't keep up. So what is Hopsworks? Hopsworks is, it's a front end. I'll do a demo hopefully at the end, given enough time. But we try to keep the abstractions quite simple. So what we have are this notion of users. We want to have in-place sharing of data, not copying, and we have datasets. So in order to group users and datasets together, we introduce an abstraction called a project. It's pretty straightforward. So here's project 1. It has 2 users and 2 datasets. Okay, so project 2 will just be 2 different users and 2 different datasets. And we can see dataset 2 was in both projects. And here's project 3, which again has dataset 2 involved in it. So this is the basic abstractions we're building our model around. So datasets, users, and projects. So what is a user? A user is somebody who logs in. You authenticate with, we have a native JDBC realm. We have 2-factor authentication, and you can plug in LDAP if you want. What is this project? Well, the project consists of our users, the members, and members will have a role. So if you're in a project, you'll have a role as either a data scientist or an owner of the project. So you'll have different privileges depending on your role. And inside the project, you will have data sets. And a data set belongs to one project. It has a home project. But you can also share it then across projects. So what are the privileges associated with the roles? Well, if I'm an owner of a project, I can upload data, download data from it. I can add people to my project, take people out. I can share data sets with other projects. But if I'm a data scientist, you're basically restricted to running programs, running analytics jobs, and maybe requesting access to data sets outside it. So we're trying to keep the set of privileges relatively small and manageable. But this may be extended over time. We have another project that builds on this called Biobank Cloud, and there we have like 6 or 7 roles. So this is quite extensible. So the interesting thing here is, as opposed to say a system like Sentry, is that this is GitHub, right? This is creating a project, adding users to your project, and changing the roles of the project. You're basically saying to the project owner, it's your job to manage membership of the project. It's your job to manage ownership or the particular roles for the users. So we're delegating administration privileges to users. And that's very different to, say, Sentry, where you have to mail sysadmin, who has the only person who has privileges to update roles and groups in the system. So we're trying to make it easier. And the other thing we're trying to do is, for sharing data sets between projects, we want this to be like Dropbox, right? You right-click in the data set, you say, share it with this project, and it appears up in their project. So how do we implement this? This all sounds nice and well. There's some clean abstractions here, I think. But how do we actually implement access control? How do we ensure that users in one project can only access the data within that project and not copy data out to another one? And what we're doing is we're actually delegating the enforcement of access control to HDFS. And behind the scenes, what we're doing is, although you authenticate with a particular username, every time you create a project, we're creating new user IDs per project. So unique user IDs per project. You can consider it to be a role per project. And then for every time we create a data set or a project, we create new groups. And users will be members of multiple groups. So effectively, what we're doing is that the Hopsworks at the front end and the Hadoop at the back end will share the same users and groups in a common database. And this is very different to Hadoop. So those of you who are familiar with Hadoop, will know that Kerberos is used as the main source, as the main platform for authenticating users. And in Kerberos, you will have a single Kerberos identifier, and adding new Kerberos identifiers like this is going to be expensive, okay? Right. So the nice thing about putting this metadata in the same database is we can now guarantee the integrity of our privileges and the actual data it's representing. And we do that with foreign keys. And what that basically means is if you remove a data set and you do it from the file system, any particular group associated with that data set will disappear, right? And then the privileges associated with users that have access to that particular data set, they'll disappear as well. So we keep the metadata and the privileges in sync. And how do we do it? So like I said earlier, we've been working on this platform for a number of years. It's called HOPS. And we have a file system, and then we have an implementation of the file system. We also have an implementation of YARN, which is the resource manager in Hadoop. And what it is effectively is a scale-out architecture for metadata for HDFS. So if you're familiar with HDFS, you'll know that HDFS has a single machine here. And you can see we have multiple machines here. And in HDFS, all of the metadata will fit on the heap of a single JVM. So it's limited to 100, 200 gigabytes. In our case, we've moved the metadata out into an open source. This is all open source, by the way. It's all in GitHub. So we've moved the metadata out to an open source in-memory distributed database, a so-called new SQL database. And this is a high-performance database, so it can scale to millions of operations per second. And what we've done with the name node is we've made them stateless. So you can add name nodes, you can add data nodes to the database, NDB, and you can add them online. And to coordinate the cluster, we have a leader election protocol, which we implement, again, using the database. So there's no zookeeper here. And if you're familiar with HDFS, there's a bunch of other services like a snapshot server, and then you have quorum servers and so on, and none of those are here. So we've simplified it somewhat. So HopsFS basically connects directly in with here, and they actually have their own databases, but you can have foreign keys that cross databases between the Hopsworks and the actual file system. So YARN looks pretty similar. So we did the same thing with YARN. We thought this worked really well, so why don't we do this with YARN? So we did. But in YARN, it's slightly different. So we don't have a set of schedulers. We have a single scheduler. But what we do is we offload the communication between these nodes down here, the node managers and the resource manager, to resource trackers. So now all the traffic here as the cluster grows gets handled by the resource trackers, and then the scheduler is just got this job of scheduling containers to applications. And that means we scale out. One issue we have here is that this database here is licensed in GPL, and this Apache code is licensed in Apache v2, so we introduce an abstraction layer. It's the same as JDBC. We call it the DAL API, and it means we can deliver or deploy these binaries separately. So, when you're installing, you have to install this and this. Now, the installation of HOPS is quite nice, actually. I won't be able to run through a demo of it here, but it's basically 6 clicks. Right? You can click your way to a cluster, and that's if you compare that to Hortonworks and Bari or Cloudera, it's a lot nicer. If you're interested, you can implement the backend yourself. If you think your database is better, and a lot of people do, you can go ahead and put out an implementation of this API and plug it in and see if you outperform our system. So our system is pretty highly performant. On the one hand, we can have a lot more metadata than HDFS. So if you're limited to about 200 gigabytes in HDFS, we can go up to many terabytes of data. We're limited to 255 nodes in our metadata architecture, but that's quite a lot of nodes. The database is limited to 48 nodes. But here's some throughput figures, and this is from a 1,500 node cluster, a 60 petabyte cluster. We took a real workload from them, and then we did some experiments on EC2. We had roughly 20 nodes. We didn't go near our limit of 200. It was too expensive. So, but with 20 nodes, we were able to get a 2.6x improvement on throughput. So not only can we have much larger amounts of metadata, but we can actually improve the throughput of HDFS significantly. And the same is true for YARN. We get some improvements in scale out in YARN. So what else can we do? It's nice. It's nice. You have your metadata in a database. That's kind of cool. But what can you do? And this is an open question for you as well. So anybody who's interested in research and wants to work on this is an open source project. We really are looking for new people to get involved. We want to build an ecosystem out of Stockholm around this platform. But we've done some projects around this. So here's one that we did. It's a problem that you have. What happens if you want to have metadata? You want to, for example, you have your data sets in here in HDFS. And you want to be able to search for, there's a guy called Adam Kagawa who worked for Spotify, and he wrote a blog entry about how he wanted to write a program to show that he was the user at Spotify who listened the most to Timbuktu, the artist. And to do that, he had to find the data sets, right? But it took him a day and a half to find the data sets, right? So one of the problems you have is how do you find your data? You'd like to, so this is a company that tried to build a unified search and update API to their file system. So in theory, what would happen is you do your updates and search via the API. But what happened in practice is people obviously don't use the API for everything. You don't have bindings to your MapReduce jobs and so on. So once the data get out of sync, you have inconsistent metadata, people stop using the service, and it becomes a bit of a mess. So we're able to keep this stuff unified. So what we can do is we can do search, and we plug in our so what we do is we take our metadata and we export it to Elasticsearch, and we have a protocol for doing that, an eventually consistent protocol. It takes about a second or two for the updates to propagate to Elasticsearch. And at the global level, what we can do is we can search for data sets and projects. We try and make it open. So if you're in a system, you can search for data sets. You'll see somebody has one. And here we have a project here that we found called LifeGene. And you can ask to share that data set. Please share that with me in this project. If you're inside a project, and now we're inside a project, search will search all of the files within that project. And those files it might be the names of the files, you might want to order them by their size, or you might have extensible metadata associated with them, which you can search for as well. So we have a tool for designing metadata. Kind of looks like this. I won't go through it too much, but basically you can add, it's like Trello. If you're familiar with Trello, it's like you're adding, this is a card, these are cards, I guess, and you're adding them to your lines or whatever they're called, these columns things. So once you've designed them, you can enter metadata, and this is an example. We have two ways of entering metadata. This one on the left, which is auto-generated from our schema, and then we have another, we ripped off Google Drive, yeah, so that kind of looks like Google Drive. There's a lot of rip-off in the UI, I'll be honest. Good, it's the way you should do it, yeah. So how does this free text search thing work? Well, we design our metadata, we enter our metadata, and it all goes in the database, nice, and we export that to Elasticsearch, and then you can do your free text search from the toolbars. So we don't have like arbitrary indexes on Elasticsearch. We've just built these indexes for projects, data sets, and then searching within a project. The nice thing here is that the distributed database is a single source of truth. So when we delete data, it gets removed from the database. Any use foreign keys to ensure extended metadata gets removed, and then those updates will be exported to Elasticsearch, which will ultimately remove the entries from there as well. Okay, so how do we do analytics in Hopsworks? That's how we do some nice things like search and managing membership of projects and so on. But you want to write programs, right? So we have two ways. This is highly inspired by Databricks Cloud, if you're familiar with it. So we have a job, batch job, which you can create. And here's an example of creating a Spark job. All this is run on YARN, I should mention as well. So this is something, if you're interested in research, if you're launching YARN jobs, you have to specify a lot of information. It's a nice area of where we can fix up and maybe do some automated inferencing of parameters for launching YARN jobs. We also support Zeppelin, and you've seen Zeppelin already by Theo, and Zeppelin is a nice interactive analytics platform. It's IPython notebook, but it supports Flink and Spark, Python, Scala, lots of different languages, and there's a growing number of what are called interpreters being written around the platform. I'm going to do a little demo, so I think I have time actually to do a little demo. So where's our dude? he was going to change something up for you. So while the man is changing the resolution or whatever, there's a couple of other features we have. So we support Erasure-coded replication. So when your metadata is in the database, it's nice. You just create a table and you do Erasure-coded replication, take the Facebook code for that, and we integrated that pretty quickly. I need my slides to see what the other features were. But there's it's scale out, and there's how's that gone? Ja, det funkar. Nej, det är inte så bra. Vi kan göra högre. Vad är det? 800 gånger 600 eller? Better. No? Okay, we'll try it like this. Right, so this is responsive HTML, but we've never really tested it. So he's really pushing me here. This should be like this small in the middle of the screen. All right, so I know it's probably gonna, yeah, see, we got done here. So I've just logged in, and you can see I have a little message here, so somebody wanted to do something. So yeah, datamin requested access to my data set, so I can do that if I want to. Normally you would see these projects on the same screen, but you can, creating a project is easy. You just go here, create a new project. Do you have a name for it? How are we doing? He's getting me down on this. I can go into a project here. So here's a project I have called Karma. I'm inside it. We have our services here on the left-hand side. We have Zeppelin. We have jobs, we have datasets, and then we have settings and members. So I'll just look at membership. It's quite easy. So adding a member to a project is basically just as simple as this. And we can change our role. We can make that person a scientist or an owner. And then the admin is me as well. Okay. So I'm in it twice. I only have 2 members. This is running on, by the way, this is running on VirtualBox on my machine at work, so it's only 8 gigabytes. So the whole stack will run on a single VirtualBox instance. Or so one thing you'll notice here is that here's some data sets here, right? And I'm not going to download that, but you can see it's pretty fast, right? Anybody who's used Hue before, it's a Python front end to HDFS. You know, we can zoom around through all these directories because it's all in the database, all the metadata. So what Hue will do is it'll start a Java process to run to talk to HDFS, and it's pretty slow. I have a job here. I won't bother running that, but you can create new jobs there, and I'll give a quick look at Zeppelin here because we talked about it earlier on. And also I had a little joke here about Zeppelin, so we see if it comes up. So this is a question for Danny here. All right, so this is Zeppelin. Oh no, it's not this one. I have to log in as another user to get it. He's got me. Well, we did have, with this one here. Here we go. Am I in as LifeGene? Let's have a look and see if it's this one. Let's have a look. Is it here? Yes, there we go. Danny, what's this? What's deep learning going to tell us? It's a pyramid, come on. It's a pyramid with blue sky. It's Egypt. Safe, you should recognize it. It's not a pie chart. You've been looking at too many pie charts here. That's the problem, you people. Okay. But anyway, so like with Zeppelin, it's nice. I just found this. Someone mailed it on Facebook yesterday. I said, I'll just dump it into Zeppelin. So it was pretty easy to do. You know, you can mix and match Markdown with some Spark code. So here's some Spark code here. We've had a lot of flinks, so let's see if we just run some Spark. I think I might have run this earlier on. How are we doing for time? I don't want to go over time. Okay, I'll finish up now. Let's see if it runs. Something's running, 40, 50, 60%. Oh yes, we have liftoff. Okay, so there you can see I just reran a query which is running on an RDD, which is a data set in Spark. And one of the nice things of Flink is they have a lot of built-in graphing. And you can see you can even get tabular format for data. But they have a lot of built-in JavaScript UIs for this. Okay, I'm not going to do too much about sharing data sets, but like I mentioned earlier on, it's pretty trivial. You just right-click on the data set and share. We can compress them. We can add our metadata and so on. This is in beta, right? So we don't have great documentation as of yet, but we really are looking for people to contribute as well. So even if you're not a researcher and you just can program some AngularJS, that would be brilliant for us. Automated installation, 5 clicks install, that's the other thing. And most importantly, it's tinker-friendly as a platform. Okay, so that's it. So what is HOPS? Or HOPS Hadoop. It's a new distribution of Hadoop. We have this front end called Hopsworks. We're going to provide as a service at the SICS data center. We're still looking for, obviously, more committers and developers. The more we get, the better. And No, that's not going to work. I'm not a Mac person, as you can tell. I'm a Linux guy. Slideshow. No, it was like a slideshow. Here we go. Presenter view. Play. Play from start. No. Play from here. Play from there. Play from current side. There we go. I had some nice graphic at the end. I just wanted to show you. No, that's not it. Oh, we have tons of people to thank. I mean, look, I think there's a bunches of people here, so I won't name names, but we have, at the moment, maybe 8 or 9 people working on it. And we've had a lot of alumni who are all over Stockholm at the moment. That was it. I'm finished. Thank you.
Thanks, Jim. So, questions?
I got away easy.
Danny.
Hi. My question, I'm a bit confused about the underlying mechanism because you mentioned Spark and you mentioned Hadoop and you mentioned Flink. So
mechanism for what? It's
which
YARN. Sorry, this is YARN. I mentioned this. Everything will run on YARN.
So, in other words, you can connect to any Hadoop-based system.
Well, Hopsworks is no is the answer. I mean, you can. The problem here is issues related. There's many features would disappear, right? So, firstly, the search will disappear. So you can't do that in HDFS. You can't take the metadata from the name node and export it to Elasticsearch. It's just not going to work. The authorization model that we have won't work if you have Kerberos enabled, right? Because the way Hadoop works if you have Kerberos enabled is that your client will talk to the name node or to YARN's resource manager with Kerberos, expect a Kerberos ID, and authenticate you based on that Kerberos ID, but you can't change your ID. You can't just say my ID is this project-specific identifier. So we separate authentication, which is what we do at our J2E server at the start. So you can plug that into Kerberos even if you want to, or you can plug it into LDAP. It's pretty trivial. We have a native database implementation of authentication as well, but the authorization parts, the identifiers used for authorization, they're stored in our database. And then we use foreign keys to link them to the actual projects, and then we use them to link those to the data itself.
But just a question, but anything that runs on YARN should be able to run on this system, right?
Yeah, sure. Yeah. I mean, you can run, so like if there's a project called Slider, if you want to run Kafka here on it, you can run that.
Okay. We run on YARN.
Oh. Great.
Okay,
so we have this service thing on the left.
We should have graph lab. Great.
The process will be actually to not let that grow. So anybody who's used Hortonworks, Ambari, or Cloudera Manager will know that you have 20 services when you come in, and the first thing a user sees is like Squoop, Zookeeper, Uzi, and they're going, "What the hell?" I still don't know what all those services are actually. So the idea would be to keep it nice and clean to a small set of widely used data processing networks. So that means Spark for the moment for Flink, and. Well, yeah, sure. We're open to contributions.
We are friends.
We accept PRs.
All right. So we'll add Graph Lab. Great. Thank you, Jim. Yeah.